So we'll be doing a workshop on building an adapter for MTConnect purposes. So just a little bit about TechSolve real quick. We're a founding sponsor of the MTConnect Institute. We're also a NIST Manufacturing Extension Partner affiliate. We're an Ohio Edison Technology Center. We do reside in Ohio. I'm sure if you've been past the booth, you're aware of our Viz suite. But we also do a lot of advanced machining research in our lab, solving machining problems, doing cut testing, testing fluids, things of that nature. So Sequin and I will be taking you through basically building an adapter this afternoon. So first we'll give you a quick overview of MTConnect since you've already had one. Talk a little bit about adapter basics. Talk a little bit about the open source frameworks for MTConnect. And then we will get into actually building an adapter using the C# framework. So quickly, we will primarily be focusing on this lower portion of the MTConnect data stream. We'll be talking about the adapter CNC machine communication and then the communication between the actual MTConnect agent and the adapter. So what's an adapter? Simply, the adapter is the liaison between the machine or some other input device that you want data from and the MTConnect agent. The adapter has two primary functions. It's to get the information from the device's current state, such as controller mode, axis position, axis load, feed overrides, etc. And it needs to send that data up to the MTConnect agent. The adapter can be a simple piece of software or a combination of software and hardware. Some examples of hardware and software are basically you could have a device that plugs into the CNC-IO bus, picks up the signals from the bus, and then sends that information up to the adapter. To the agent. Or it could literally be a data acquisition system that you attach to the machine to specific relay points to pick up control signals in the machine, and again, use a piece of software to send that information again to the agent. Adapters can also be used to collect data from sensors such as accelerometers, thermocouples, or possibly other human interface devices, barcode readers, notepads, cell phones. It's unlimited. Okay, so let's talk a little bit about the device adapter communication. So the machine tools, PLC sensors, human input devices expose various types of interfaces. They typically can be connected either TCP/IP, RS-232, RS-48, etc. Or the adapter could actually be embedded into the operating system, in which some cases they actually do that. They actually pick up the data directly from memory within the operating system. They can also vary quite significantly between manufacturers, control, the vintage of the control, and potentially available options that are on that control. In the case of some vintage CNCs, there may not be a way to actually get data directly from the control, and that's when you typically have to do some kind of combination of taking and plugging into an I/O rack, or again, taking some simple data acquisition system to pick up some of the control signals and use that to actually extract information from the machine. What you're going to find when you're building an adapter is that you're probably going to spend the majority of your time up front looking at how you have to interface with the control, how to get the data that you want out of the control, and get that data sent up to the agent. So as far as communication between the agent and the adapter, adapters use sockets typically to communicate, which is basically just a generic term for an inter-process connection. We typically use the TCP/IP protocol, very simple to implement, makes it really easy to talk between the agent and the adapter. So while we're talking between the agent and adapter, we have an agent-adapter protocol. We have heartbeats. And what happens is, essentially, the adapter will sit there and listen for clients to attach to it, typically open source agents. And when it hears a ping from the agent, it then returns with a pong along with a frequency. And this frequency is telling the agent how frequently that adapter is going to listen for a ping and respond within a certain period of time with a pong. That way the agent knows that its communication with the adapter is good. If it doesn't respond, then it knows that, well, one, either the machine containing the adapter is turned off, or there is some other communication problem between the agent and adapter. So basically, this makes it simple for the agent to handle issues that may arise with the network. Now, the heartbeats are optional, but again, it's highly recommended. So here's an example of some of the data that comes from the adapter, typically. This is the format that the open source agent recognizes to transfer data between the adapter and the agent. So it's very simply a date timestamp, the name of the variable and its state. Here's a couple of examples of several different data items. Then we have a second example here, which is one of a condition. So basically, is my temperature or my axis okay? Am I having some kind of system problem? This is the format that it'll come up in. And again, it's typically just a timestamp, name value for the simple data items. For the condition, you got the timestamp, name, level, the native code, the severity, some qualifier, and the text. The time series and the assets are some other specific data types that are used to relay more complex data. We're really not going to get into that unless we have some time towards the end, in which case we will cover that. If you look at the presentation, at the end of that, you'll see an addendum that really goes into fairly good description of the time series and the asset type data constructions. Okay, so adapters are not part of the standard. Why do we need the adapters? So as we kind of iterated before, adapters provide the ability to connect devices using different communication protocols, connect to a variety of devices such as CNCs, sensors, etc. And it can use a common generic agent. So the adapters also provides a clear separation of functionality. The adapter is responsible for collecting the data from one device, typically a machine or some other human input device, filter out duplicate data, and then write that data to the agent as text. The agent is responsible for collecting the data from the adapters, formatting that data into the MTConnect standard XML stream, and then to listen for requests from client applications, then respond with the appropriate data. All right, some basic skills that you're going to need to build an adapter. You have to be able to, first of all, format the time, and we use universal time coordinates as the standard. It's simply the year, month, date, the separator T, hours, minutes, seconds, fractions of a second. And this basically follows the ISO 8601 standard. As an example, you got the date. I knew I was going to do that. Of 2015, 04, April, today, 30, 1815. We're a little bit past 1815. And then the Z for Zulu. So you also need to be able to create TCP server sockets and listen for clients. You have to be able to read and write from the socket. And this then also assumes that you can get the data from the device. Well, simpler yet, the MTConnect Institute has gone through a lot of trouble to develop some frameworks in C++, C#, Ruby, and Python to handle most of this work. So for this lab exercise, we're going to be specifically focusing on C#. So what's the framework do for us? Well, the framework provides communication and protocols, provides the data formatting, It provides detection of changed data items, so it knows if the data item has changed or not. And then it supports the typical MTConnect data types. So we have the simple kinetic, here we go. We have three categories. We typically have data items. We've got events, samples, and conditions. The samples and events are fairly simple data items. Again, the condition can be a little more involved. You have messages, which are basically discrete type messages, time series, and then assets. So these are typically covered in the part 2 of the standard. Assets are covered in part 4 of the standard. So the program's responsibilities are basically determine the controller configuration, create the data item for each parameter that you want to monitor, then gather the data periodically or on some event callback that triggers the data to be updated. And then you only want to send changed data items. There's no point in sending repeated data items. Okay, so a typical design approach for designing the adapter, you need to gather the information for the following components. You need to gather the information on the controls and paths. You want to gather information on the axes, the machine's systems, and then typically you'll want to gather information on cutting tools. So what are we interested in the standpoint of the controller and the paths? Typically, people want to know what the controller mode is. You want to know whether it's in an automatic state, if it's in a manual mode, manual data entry, and you want to know what the execution state is. Is it actively running a program? Is it interrupted? Is it stopped? And then you want alarms, which are typically conditions and possibly messages. Program name is always important to you. Program comments can be important. Line, block, and then you get into overrides, path feed rates, part count, path positions. The type of information that you want about your axes and spindles are position and angle, typically. In the case of linear axis, you want position. If it's a rotary axis, you may want the angle. For spindle speeds, loads, alarms, and temperature information. For systems, there are usually a few conditions associated with a few special alarms. Coolant, hydraulics, pneumatics, and electrical. Okay, to get to the controller mode, we'll use an example from the C++ library that uses the FANUC focus library to get information from FANUC control. So if we want controller mode, then we're going to use the focus ODBST status structure and make a call to the FANUC library using the CNC statinfo function. What that will return to us is a status variable that will have a byte that will indicate if the byte value is 5 or 6, then the CNC is in the manual mode. If the status byte is 0 to 3, it indicates that the CNC is MDI or edit mode. Any other value in the CNC is assumed to be in the automatic mode. So this is how some of the basic controller modes are mapped. I know Joel had mentioned earlier at the users group meeting the MTConnect community, the user page, and you will find a lot of information on this website on best practices, for example, defining what the modes are, or if the motion is in hold or wait, and things of that example. Okay, a little bit about alarms and conditions. They take a little bit of special handling. So it's very possible that you could have multiple conditions can be active at the same time. So conditions are unique by type and native code. And this is basically an MTConnect implementation decision. So one or more conditions can be cleared at the same time. So the representation, you have the conditions, you have the name, you have a level, which is defined as either normal, warning, fault, or the data item is just not available. You have a native code, the native severity, and then possibly some qualifier such as high or low, and then there could be some textual message along with that condition. So how do we handle the alarm list? So the framework provides tools to mark the conditions when they come up, and then a sweep to collect and then close alarms that are no longer active. So for every alarm that's in the list, you add it to the condition of that type. If an alarm is not added, it's cleared. So then add marks the active alarms, and then the sweep finds all the alarms that are not marked and then removes them. So again, using the focus as an example, this is a call to the focus library to get the alarms from the machine. It identifies any alarms, and then we'll add that alarm to any specific condition. So in this particular case, we had 3 alarms. We had native code 416, 912, and then 649, general fault 1, 2, and 3. So in the next data gathering cycle, we find that 912 is now clear, but we have a new fault, 214, general fault 14. So what you see now, this is the original table. Now we have 912 is cleared, but 214 has been added to the table. So when all the alarms are cleared, the normal is sent, and then as you can see, that clears all the alarms. Simple conditions, if the data source sends an event and the alarm starts and stops, you can use a simple condition. Simple condition requires an explicit clear when that condition is no longer active, as we just showed you. How do we make an adapter dynamic? So far, what we're going to show you is basically going straight forward and defining all the data items, but it is possible with some controls to query that control and determine how many accesses it has, what the paths are, and other aspects of the control. So by doing that, you can then automatically configure the adapter to pick up those specific data items. The open source FANUC adapter is a good example of a self-configuring multi-path access adapter. So I highly recommend that at some point in time you take a look at that open source adapter. Okay, I want to talk a little more in detail about the actual C# framework that we're going to be using. Sorry if I just shot somebody with a laser. Very sorry, yeah. Fortunately, they're low powered. Okay, so the main class that we have in the framework is the adapter. This is the abstraction of the actual adapter that contains a framework that does most of the work in communicating with the control and communicating with its clients. Then we have the data item class, which actually constructs the other types of data items that we actually have to use to collect the data, determine if the data is new, fresh, or if it hasn't changed, and then it provides formatting and configuration of the data that has to then be sent up to control. And we have one other abstraction that we added in 1.2, which was assets. This is currently only covers cutting tools, but I know there are plans to expand this into part type information, and some other types that will be involved in the later standards. So this is the basic framework that we use to build our adapters. It really simplifies the whole task. So the adapter class, basically you got fields that define the specific types of data that basically the objects and variables that you're going to use to create the adapter. And the other primary thing you're going to work with is the methods. These are the actual functions within that class that will basically handle your creation of the adapter, adding data items. The begin is what you actually use to check for condition changes. The heartbeat handles all the heartbeat protocol. You've got functions to listen for clients. You can remove data items, remove a single data item, and so on. So this makes it very easy for you to write an adapter for a specific machine to build on top of this. And all you have to do is essentially define the data items you're going to use. You have to add them to the data item list, and then you have to go get the data to populate the values for those data items, and then eventually send that data to the clients. Okay, so I pretty much talked about this. Again, this is talking specifically about the field aspect. And again, going over the methods. So again, looking at the adapter class, basically I would take, so for instance, I want controller mode. I would define an event called controller mode. I would use the add data item to then add the controller mode to the mdata items, which is basically just a list of all my data items. So it takes care of all the bookkeeping for you. And it gives you the mechanism to add your individual data items. Okay, so the adapter lab. Hopefully everybody has downloaded the lab from the website. So basically what we will be doing is, what we're going to really focus on is these first 6. If we have more time, we will get into the cutting tool and the time series, which are again a little more complicated. But we want to make sure you understand the basics of how we use this framework to build the adapters. These can be done at a later time on your own if you wish. You can either follow along with us, building off of the first case, or you can just simply take and open up each lab as we go and just use that to execute. So what we're going to be building is an adapter that's going to basically simulate a 2-axis machine. So we have a simple start-stop button. We have the emergency stop that we check to invoke the emergency stop. We've got controller mode here, which is automatic, manual, MDI, or edit mode. We have the execution state, running, ready, stopped, or feed hold. Then we have a new data item that we just added at 1.3, which is the functional mode. So this is really defined to tell is this machine in setup mode? Is it in production mode? Is it down? It's really to give us a little more functional information about the machine. Did it again. There we go. Okay, we have a place to put in the program, part ID. We can do a simple text message. We have a method to change the axis load, the axis position using sliders. And then we're going to simulate the rotary axis again with load and speed. And then we have a few different alarms that we can throw to implement the conditions. And then if we have time, we will go into this add tool to look at the asset. Okay, so at this point, we're going to switch over to Sequence Computer. And what we have up here, I wanted to show you the, I know they talked about in the user group meeting, but I wanted to show you the actual GitHub site, which is the MTConnect site for the different tools, open source tools that we provide. So this C++ agent is broadly used to provide a nice standard agent. This is an excellent tool. We have the schema. We have the MC2 adapter lab. And we have the .NET SDK. This is really what we're going to be using typically when we build a new adapter. Okay, I'm going to go down to the, a little bit further to the agent, or the adapter. Where's the adapters at? Okay, so this is where you go to actually get the adapter frameworks. Actually, these are the open source adapters. This is the framework. Okay, you want to switch over to the first lab sequence? Okay, so the first thing we're going to do basically is add a simple event, which is the machine availability. Okay, first thing we actually have to do though when we're building a new adapter, so this is our machine tool adapter that's going to use the adapter, the C# framework. First thing we actually have to do is go to the reference and add the SDK DLL, which is right here. That's the .NET SDK. Then we have to go up in the namespace and add the using MTConnect to be able to access the adapter. Now what Sequen's going to do here, he's going to actually add the adapter so this actually constructs a new adapter. Then in the constructor, so we're going to talk a little bit. So the start, when you hit that start button, it's going to execute this method. So this is where he has to actually implement the MTConnect adapter at. So he's going to assign a port. And this actually will start the adapter up. When you hit the stop button, this is going to actually stop the adapter. Okay, did you add the data items? Okay, so he's now adding the event mAvailable. So he's going to create a new event. He's going to name that AVAIL. Then he's going to come down to the constructor. And he's going to add the available data item to the data item list. Now, because the availability data basically tells you that that machine is up and running, because this is a simulated machine, we're going to set this to always be available. Now, normally what will happen is the adapter will talk to control. If it gets a response, it sets that available item is available. If it doesn't, then it simply sets that to unavailable. And if any clients talk to it, it will tell them that that machine's not available. And now we are going to run it. He started the adapter up. And now he's starting up the agent. And as you can see now from the agent, we get this nice formatted output. So the availability type, the name is avail, and its value is available. Now I wanted to actually show you quickly the actual XML here. And what's really important here is when you're naming your data items in the adapter, this name is what the agent is going to be looking for to take the values for that data item and plug it into the XML data stream. So it's very important to remember, whatever I name that in my adapter, I have to have the matching name when I set up my XML. Okay, so we can switch back to the presentation, please. So hopefully at this point you've concluded step one, which is to add the availability item. For step two, we're going to add the eStop. So the eStop is another event, so essentially you're going to go into the machine tool adapter, create an event, MEStop. You're going to add a new event named eStop, and then you'll go to the constructor and use the madapter.addDataItem, the MEStop, to add that to the data list. And now you're going to have to go to the gatherTick method. Now this is the method that we call on a periodic basis. We're going to use a timer to actually call that on a specific frequency, and it's going to go through the routine to query the CNC for the specific data items that we're interested in. Then after it collects all that, it's going to send any data item that's changed to the client. Okay, if we can switch back to the sequence computer, and you'll want to go to lab 2 for this, if you're following with us. So he's going to add a new event up here, MEStop. And then he's going to instantiate an event with that name, eStop. He'll come down to constructor, and again, add the data item, MEStop. And under gatherTick, now what he's going to do here, he's going to type in this adapter begin. Again, that's to start the process of looking for any kind of conditions that are throwing faults or warnings to add those to the alarm table. And it will also check to see if any alarms that have been added have been cleared. It will also, so it does the mark and it performs the sweep function for you. Now he's adding the code in to emulate the eStop. So when you check that checkbox, it says eStop. If it's checked, it's going to say it's triggered. When you uncheck it, it's going to go back to the ARM state. So he's going to run it. So now you see the emergency stop type, name eStop, which is what we named it in the adapter, and you can see that it's armed. Now if he will check this and refresh it, you now see that it's triggered. And again, here in the XML, you can see, again, the name is eStop. So you have that correlation between the name of the adapter and, again, the XML stream. Okay, so we can switch back to the presentation again. So we're going to go into the lab 3, and we're going to add 2 more variables. We're going to add the M mode and the M exec. So we're going to, basically, the M mode is going to be the controller mode of the machine, and we're going to name the execution state of the machine exec. So as you can see now, we're kind of going through the same process for each data item. We create the data item. We basically create it as an event or a sample or a condition. Then we go to the constructor for the adapter, and we add that specific data item to the data item list. And then again, we're going to go back to the gather tick method, which the timer will call on a periodic basis, to add the code to actually get that information from the controller. In this case, it's going to take it from our form. So we can switch back to sequence computer. Now again, if you want to just load the lab 3, this is already typed in for you. So he's adding the E mode. Cut and paste works great when you're writing code. So we got the name mode and the exe. He's going to come down and add the data items to the data item list. You better add a send data. Okay. I'm sorry, it's getting ahead of you, Sequin. So again, this is just querying the checkboxes to see if they're checked. Or actually, in this case, these are radio buttons. So the radio button will only allow you to select one specific item. I'm sure everybody's familiar with radio buttons. Okay, we can run that. So now as you see, as he's switching these values, you can see down here in the agents XML that these values are changing. And again, the execution name is exe, same as we named it in the adapter. And the controller mode, there it is, mode. Same thing, just what we named in the adapter. Okay, we can go back to the presentation. Okay, we're going to add some more data items. We're going to add 2 more events, the functional mode, the program name, and then we're going to add a message. And again, once after we add those variables, then we're going to go down to the constructor, add those to our data item list, and then, as we've done in the past, we're going to modify the gather tick method to collect that data from the form. Okay, can we switch back to sequence computer, please? And again, if you'd like, you can just open up the Lab4 project, and this should already be typed in for you. Okay, now he's making the modifications to the gather underscore tick method to query the controls on the form for the values. So for functional mode, it's easy. It just has to go read that drop-down control to see which specific data item you picked and pull out the text. And for the program value, we just simply read the text box. Now he's adding now, so when the cursor leaves the text box, it's going to update the text in that message. So this is a case where an event is actually triggering the collection of data. So as you can see, when he makes changes to the machine tool, the adapter takes those changes, sends those changes up to the agent, and then the agent is showing us the changes in the data. Okay, so all he did was type something in that time, exited the text box, and you see it updated on the XML stream. Okay, we can switch back to the presentation. So we'll go on to step 5, and now we're going to start getting into another data category, sample. So the sample is basically sending real types of information, position, load, things that are defined by real variables. And again, we're going to go through the same process of adding the new data items, adding the data items to the data item list, and then again modifying the gather_tick to collect that data and send it up to the agent. Okay, we'll switch back to sequence computer. So as you can see, as he's typing this in, and if you're typing, keep doing what you're doing. If you're not typing, it's important to understand the data types that are defined by the MTConnect. And again, those are all defined in Part 2 of the standard. So he's in the data items for the linear axis and the spindle. Okay, so now he's adding the methods to the gather_tick that will periodically scan the form for any data changes. And then he's adding the code to the actual events that will be triggered if there is a change to the input control on the form, which again is your event-triggered data collection process. So while he's doing that, we can talk a little bit more about the send change data. So at the end of that gather routine, what that's doing is it's going through the data item list, checking each data item to see if it's changed value since the last time it was checked. It then takes the changed data items, and those are the data items that it actually sends the new information up to the agent. That cuts down on unnecessary network traffic. So we've really taken great pains to minimize network traffic. Okay, so now you see a linear axis, and you can see the current position and load saying unavailable. There we go. Okay, so it's responding to changes. Okay. Okay, a little short on time. Can you just pull up the Lab 6 and build it? Sure. So we're a little bit longer than we were hoping to run here. We're just going to get through the first 6 labs. Again, I encourage you to go through the addendum to look at the information on adding asset data types and time series. And you can simply, again, you can simply just open up the individual lab projects and build them and run. But go through the code and look at the code. And this is basically, anytime you build an adapter, this is essentially what you're going to do. You've got to get the information on the control, figure out what type of communication you have to do. Most of them are going to be TCP/IP, which really simplifies using the framework. The important thing is, how do I get the data from the control? FANUC is simply using the focus library calls. Other machine tool builders actually provide you adapters, but if you ever have to build one, this really simplifies the whole process because the framework handles most of the work that actually has to go on. Okay, is this 6?
Yes.
Okay, I wanted to get to this because this is actually implementing the conditions. So now as he starts triggering some alarms, you will see conditions being added, going from normal to false, or warnings in this case, some of them. Something went wrong. I like that. Okay, I'm afraid that's all we have time for at this point. Can we switch back to the presentation, please? I'm going to skip on down. So I'll take a few minutes for questions. We went through a lot in a very short period of time. Okay, no questions, great. If you do have questions, you can contact Sequin or myself at TechSolve. Will Sobel is an excellent resource for any questions around the open framework and MTConnect in general. So I'd like to give my thanks to everybody for attending. Specifically, I want to recognize Will Sobel from System Insights So basically, this presentation and the lab were based on Will's previous MC2 workshops. Without his help, this never would have happened today. I'd also like to thank Helena Hailu from AMT for supporting the organization in this presentation. So thank you.